Hi, this is Mark Schuyler. We're going to go over exponent rules today. These are all the rules you'll need if you're taking the SAT or the ACT in the coming months. I'm going to try to start off with the easy rules and in a very short video, 15 minutes max, go all the way from the easy to the hardest rules. So besides not understanding fractions, I would say not really knowing your exponent rules is the next worst thing that could happen to you if you want to get a high score on the math sections of these college entrance exams. You got to know fractions, they're the fundamentals, but exponents, it's shocking to me really how many of my students are not very good at these rules. So without further ado, let's jump in and look at some of the easy rules. And I'm going to label that right here. And I'm going to make that color a lot better because that's atrocious. Okay, sorry about that. So yeah, easy rules. It all starts with understanding if you have A and it's been raised to the second power, A times A, and you want to multiply that times, say, A to the third power. What's the right answer? Well, they're hoping you fall for A to the sixth, right? Because 2 times 3 is 6. But it's not true. It is not A to the sixth. Instead, it's A to the fifth power. Let me write that here. Okay. Why? Well, A times A over here, you could think of that in parentheses, times A times A times A. So clearly, if we count up the number of times A is being multiplied against itself, it's A to the fifth. Now, here is a very different situation, what I'm about to show you. If you have A to the second inside of parentheses, and you raise that to the third power, that is A to the sixth. And again, it really helps to visualize it. What we were given in the parentheses is A times A. But raising that to the third power means you want that quantity times itself a total of 3 times. So there we go, with 3 sets of parentheses, you can see that that is indeed A to the sixth. A times A times A times A times A. I think I said it enough times. So these two are mucho importante. If you confuse them on test day, when it's time to add the exponents and when it's time to multiply them, it's going to be a long morning at the test center. Things will not go well. Exponent rules, very important. Now, there are some other easy rules. I'm going to change colors. Let's get going with another color. You also need to know that when it comes to adding exponents, if you wanted to add A to the second to A to the third, you can't do it. You can't just simplify that and reduce it. All you can say is it's A to the second plus A to the third. Now, let me show you a situation when you can add the exponents. Let's say I had A to the third plus A to the third. Well, there's a silent 1 in front of each of these. So you could actually say you have 2A to the third. But you can only add the exponents if they have the same base and they're being brought to the same power. Let me give you one more example. If you have 2A to the fourth and you want to add that to 3A to the fourth, can you do it? Of course you can, because they're both A to the fourth. So you add the coefficients in front and you have 5A to the fourth. But if anything had been different, if it had been an A over here and maybe a B there, then you wouldn't be able to do it. Or if it had been A and A, but one was to the third power and one was to the fourth, then you couldn't do it. So this is all part of understanding the easy rules. Now, I want to be really thorough here. Got to have the basics. So in red, I'm going to put a situation that is the inverse of the situation up here. Up here, when we're multiplying exponents, you'll remember you're really adding. So guess what happens when you're dividing exponents? Let's say you had A to the sixth, and you had that over a to the second power. Well, this is a perfect time for the SAT or the ACT to trick you, right? They're into tricking you a lot. You might think, well, we're dividing, so 6 is divided by 2, and it would go in, 2 would go in 3 times. So you might think the answer is a to the third, but oh no, it's not a to the third. Instead, you have to remember that, well, if when you're multiplying exponents, you're really adding. When you're dividing exponents, what you're really doing is subtracting. So if you subtract the 2 from the 6, it would give you a to the fourth. Again, if you just need to see it visually and you need to think about it, which would really help you make sense of remembering the exponent rules, right? Is if you saw a times a times a times a times a times a to the sixth, divided by a to the second, well, these guys would cancel out, leaving behind a 1 everywhere. 1, 1, 1. But then you would end up having a times itself 4 times a to the fourth. Yeah, it was really like subtracting. It wasn't at all like dividing. So here are pretty much the easy rules. Let's change slides and take a look at the hard rules. All right, and I'm going to label it up here. Okay. Now that we've got our easy rules all rock solid in our brains, we'll take a look at the hard rules. So it starts with understanding what it means if you bring a fraction to bring an exponent to a fractional power. Yes, let me say that again, and I'll actually write it out so you can see it. Let's say you take a and you raise it not to the second or the third power, but you raise it to a fractional power. Well, what does that mean, a to the 1/2? Well, it really means, and this is the one I always go back to when I'm trying to remember the harder rules. I go back to this one. It means the square root of a. So if they had asked you, I don't know, let's say 9 to the 1/2 power, that would be the square root of 9, which is really 3. So pretty easy if you remember that. And what's really going on here, let me just kind of explain this in massive detail, is did you see the 2 in the denominator of the fraction 1/2? You know, that 2 right there? It's really here, but we don't bother to write the 2 inside of that little hook of the square root. If it's a square root, we don't bother to put it in. We know there's a 2 there. And by the way, we don't even bother to put a to the first power, but that's where the 1 in the numerator is coming from. That being said, guess what a to the 1/3 power what that really means. Think about it, and if you guessed that it meant the cubic root of a to the first, you're right. If we were asked what is a to the 2/3 power, well, it would be, look at the denominator, it would be a cubic root, but of a squared. So let's use a real number now and see what we can come up with. How about 8 raised to the 2/3 power? Seems complicated, but we know it's going to be the cubic root of 8. And you can actually figure that out right now. The cubic root of 8 is 2, and then 2 squared is going to be 4. Or you could say, well, 8 squared is 64, and the cubic root of 64 is 4. So it doesn't really matter if you take the 8 and you square it first, and then find the cubic root of that relatively large number, or if you take the cubic root of 8, and it's a pretty small number, 2, and then you square the 2. For all practical purposes, it works out on the SAT and ACT to the same answer. And if you want to do it quickly in your head, you might want to take the square root or the cubic root first, and then square what's underneath the cubic root sign or the square root sign. So see how these are the hard rules? Well, let me give you one more to try out. I'm going to go back to red. This will be pretty important. Let's say we have x to the 3/4 power. What does that really mean? Well, it means we're going to have the x underneath this radical sign, but to what root? Well, it'll be the 4th root of x to the 3rd. If you can't remember, if you think it's the cubic root of x to the 4th, you're not sure, oh my God, which one is it? Go back to remembering what a to the 1/2 is. We know that a to the 1/2 is the square root of a. That'll help you figure out what number belongs here as the index and which number is the exponent. All right, we're not quite done with the hard rules. There's a continuation here. One more round of hard rules and you will be ready. You have to also know what it means if x or a, some variable, is brought not just, say, to a fractional power like 1/2. You have to know what it means if it's brought to a negative power, like x to the negative 2nd or x to the negative 3rd. What does that mean? Well, don't be fooled by the negative sign. The answer will not be negative. You're actually going to get a very small number that's positive. It's a number that's smaller than 1, but greater than 0. Here's what you would actually do. Let's give you a real number for x. Let's say you had 5 to the negative 2nd power. What that really means is 1 over 5 to the 2nd power, which simplifies to 1 over 25. Let's try out 5 to the negative 3rd power. Well, that's really going to be 1 over 5 to the 3rd, which is 1 over 125, a pretty small fraction. Notice the smaller the negative power you bring it to, negative 3 is even smaller than negative 2. The smaller your fraction is going to become, the closer to 0. If you're looking at something really small through a microscope, not using a telescope, but using a microscope, say you're looking at an Ebola virus through the microscope, you might say it is 10 to the, I don't know, I'm making this up, 10 to the negative 7th power. This is 1 over 10 to the 7th. And 10 to the 7th is a 1 followed by 10 zeros. Let me put the commas in where they belong. So that's 1 over 10 million. So 1/10,000,000th of a whatever centimeter is how small the Ebola virus would be. So if you look through a telescope, you might be talking about the nearest star is 10 to the 7th light years away. Whatever, a star is 10 to the 7th light years away. But through a microscope, you would be looking at something really small. It might be 10 to the negative 7th. So 1 over will give you the fraction. Now, I'll tell you when things get really tough on the SAT or the ACT. We're just going to wrap up here and imagine a situation where they combine fractional exponents with negative exponents. Like you might get 8 raised to the negative 2/3 power, and that might just short circuit your brain. You're like, oh my God, I forgot my rules about fractions. I forgot my rules about negatives. Well, take it slow. If you want, remember what the negative sign means first. It means you have 1 over 8 to the 2/3 power. Okay, that's 2/3. And then you can simplify the denominator. You can say, well, the 2/3, the 3, means it's the cubic root of 8 squared. And then you can actually work on that by saying it means the cubic root of 8 is 2, and 2 squared is 4. So really, it works out to the fraction 1/4. 8 to the negative 2/3 is really the fraction 1/4. Let me give you one more example, and hopefully you can get this one all by yourself. Let me put it in dark purple. Let's say you had 27 to the negative 1/3 power. How can you rewrite that as a positive fraction? Remember, that negative sign doesn't mean negative answers, just means you're going to have a very small fraction, positive fraction as an answer. Well, first of all, the negative meant 1 over 27 to the 1/3 power. And then you can work on the denominator by saying, well, that really means the cubic root of 27 to the 1st power. We're getting the first from the 1 in the numerator of 1/3, but who bothers to write that? People really don't write that. And then what is the cubic root of 27? Well, hopefully you know that's 3. So you end up with a much simpler number. 1/3 is the same as 27 raised to the negative 1/3 power. So I would completely understand if you watch this video more than once. Many of my students do. Remember, it really is the foundation of a lot of the more challenging problems on the college entrance exams. If you just scan any SAT, you might be shocked to see how many of the problems involve exponents. A very large percentage of the problems will have something being raised to a power, either an outright number or a variable like x or a, and you want to feel really confident with all your rules. I wish you a lot of luck on test day, and thanks for watching.